Hello, welcome to the next episode in the Minecraft clone tutorial series. Today we're going to be finishing up chunking and getting started with some terrain generation. So I've already went ahead and cleared out our little temporary chunk that we made in the gen blocks, and we're going to just simply, for the time being, create a solid chunk of blocks, and then we will do some terrain after that. So for this, we're going to be looping over all of the X positions, then we're going to loop over all the Z positions, and then we're going to loop over all of the Y positions, and that will generate a solid chunk of blocks. So in here, I will do a for loop, and this will be for int x equals 0, x is less than size, and increment the x. Remember that we have a size that variable that corresponds with the width and the depth of the chunk, and a height variable that corresponds with the height of the chunk. So for the next one, we'll do for, and this will be int z equals 0. Z is less than size, and increment z. And then for the third one, we'll do for int y equals 0, y is less than height, y plus plus. And here is where all of the action happens. And so for now, what we're going to do is we're just going to create a block here. So block equals a new block. And this block takes in a variable, which is a vector 3. And this vector 3, for its 3 values, will be x, y, and z. That will be its position. But now we need to actually add the data from this block into the actual chunk mesh. So for this, we're going to do we're going to do var left face, because we're just going to add the left face for now, equals block dot get face, and we want faces dot left. Then we're going to actually integrate it. So we're going to do chunk verts dot add range. This will add everything from this selection here, and we want to add the left face vertices. So left face dot vertices, and then we want to do chunk UVs dot add range face dot UV. And then we simply want to increment the indices. So we're going to do the method that we did before, where we do int num faces equals 0, and then simply increment the number of faces here. So num faces plus plus. And now we will do a call to add indices and send it num faces. And now what you'll see is that if we run this code, we should see the left face for an entire chunk of blocks. That is 16 by 16 by 32. Okay, that's cool. So let's add the rest of the faces. I'm going to make a convenience method to make this a lot simpler, so I don't have to do this code here 6 times. So instead, I'm just going to go down here, and I'm just going to do a public void, and it's going to be integrate face, and then this is going to take in the block, and then the face. So face is face. And then what we'll do here is we'll simply say var face data equals block dot get face, and then we'll send in the face as our as the face that we want. And then what we'll simply do is we'll do chunk verts dot add range, and then we will send the face data dot vertices, and then the chunk UV, just the same thing we did before. We're just doing it inside of a method so we can shorten the code a lot inside of the gen chunk, which in a bit you will see that is very, very useful with the size of this. And so with this, that is all we are doing there. And so now instead of doing all this stuff, we can instead just simply do this. We can get rid of this. We'll do integrate face, and then we want to send it the block, and then we will send it the face that we want, so faces dot left, and that does the exact same purpose. So now we can go in here and we can turn around and we have all of them. So let's go ahead and do this for all 6 faces. So I'll just take this and add 6 of them, then do faces dot right here, faces dot top, faces dot bottom, faces dot front, faces dot back, and then just increment the number of faces by 6, because we're adding 6 faces to our chunk for each block. So now if we run it, we should see that we have a solid chunk with all of the faces in it. So let's give some height, some varying heights to this. Let's give it some terrain. So for that, let's go to the NuGet package manager. I don't know if it's NuGet or Nugget actually still, so maybe let me know in the comments. So you're going to be looking for simplex noise. It's the one, at the time of this recording, it has 9,000 downloads. It has a blue S logo, whatever. Just download that. It's a pretty small library here, so it's pretty nice. And what we're going to be doing is we're going to be generating a height map for this. This isn't going to have any fancy caves or anything like that. That's not for this episode. This is getting some basic terrain generation up and running. So we're going to use this gen chunk here. And the first thing we're going to do is we're going to change the return type. It's going to return a 2-dimensional float array. And here we're going to basically change that here. We're going to say float height map equals gen chunk. And it's giving us an error because we haven't returned anything yet. So let's go ahead and do this. So let's create a two-dimensional float array in here. Let's call it height map. And let's just make it equal to a new float, and it will be of size and size. This will be the X and the Z, the width and the depth. And just to get rid of the error, because I can't stand errors, I will return the height map at the end here. Let's go ahead and change this, because right now they're all just zeros. Let's go ahead and do that. I'll change that real quick. So for this, we're going to use the simplex noise library we just installed. The first thing is an optional one. We can set the seed, and I'll just do this just to show you that you can do it. We're just going to do simplex noise.noise.seed. I'll just set it equal to 1, 2, 3, 4, 5, 6. Doesn't matter. It just changes the variations. It doesn't change any settings with it. And now what we're going to do is we'll just loop over every value inside of our height map. So since we're looping over the X and the Z's positions, we are going to do that for the for loops. So we'll do for int X equals 0, X is less than size, X plus plus, for int Z equals 0, Z is less than size, Z plus plus. And then what we'll do is we'll simply do height map at X comma Z equals, and we want to do simplex noise.noise.calc pixel 2D. This takes in 3 arguments: the X position, the Y position, or in our case the Z position, and then the scale. And the scale, we want it to be really small, so we'll do 0.01 here, F, because it's a float. And that's all we need. So now we need to make a modification to the gen blocks here. This gen blocks will now take in an argument of a 2-dimensional float array. So float array height map. And now we simply need to just pass in the height map in our constructor here. So now we have access to this height map. What we can do is whenever we are looping through over our Y positions, instead of going up to height, we can go up to the value that we get from this. So what we're going to do here is we'll do int, and then we'll do column height because it's the current column's height. And since this is a float array, we're going to actually have to typecast it into an int. And then we're going to do the height map at X and Z, but we're also going to do division by 10. And the reason is because it generates a pretty large value, and our little tester chunk only has a max height of 32 blocks, so we can't really see the entire value. So it's nice to divide it, make it a little bit more reasonable for our purposes here. Not that we couldn't handle the larger one, but whatever. And then just change the height to the column height here. And now if you run it, you should see a proper little chunk is generated here. So there you go. That's some decent terrain generation. So I know that it's all dirt. We'll get into multiple different block types in the next tutorial. The problem is that we are loading every single face for every single block inside of our chunk. And while this doesn't have any performance issues when we have one chunk, if we are loading in 100 chunks, dramatically can decrease in performance. The only real blocks in that example that we had to render were all the ones on the outside. So all of the inside blocks or all the inside faces could have just been removed and the player would not notice anything. And this is the basic concept of chunk meshing. When the whole purpose of us creating this chunk mesh, merging them all into one, while it does make it only one draw call, another benefit is that we can specify which faces we want to keep and which ones we want to remove, which can greatly increase performance in the performance demanding genre of voxel game development. And so for this, we're going to actually create a new data structure here. And this data structure is going to be a 3-dimensional array of our blocks. And so we're going to do a block, and this is going to be a 3-dimensional array, and this is going to be chunk blocks equals a new block, and then we're going to have it of size. This is going to be X, Y, and Z. So we're going to do size, height, and then size here, and this will be all of the blocks inside of here. Now for this to actually work, we're going to need an empty block type. So let's go ahead and do that. Let's just go in here and let's create some block types. So I believe we haven't done it before. Let's just go here. Let's create a public enum. And let's do block type. And for this, we will have a dirt one, and then we will have an empty one. And go ahead and go to our block here. And now when we construct our block, we're going to add another argument. And for this, we're going to do block type, and we could set it to a default value. I'll do a default value of empty, and I believe that should work perfectly fine, yeah. And now all we have to do is just assign our block type to this. So we will do public block type, and then we'll do type here, and then we will simply go into our constructor and we'll say type equals block type. And now what we're going to do here is we are going to change up some stuff in our chunk. So instead of just creating the block as we do we are going to add one more little thing here. We're going to do chunk blocks. We want to declare the chunk blocks outside of the constructor here. I've been coding a little bit too much in Python recently. Okay, so let's go ahead and just go down here and I'll just put it here. And what we'll do is inside of this generation here, we will do chunk blocks. And then what we will do is we will do at x, y, and z equals block, or equals, yeah, block. What we're going to do is we're going to do one more check. So you'll notice that we're passing in the block here. However, we need to do a different check here. So we're going to revert this from column height. We're going to instead just use the max height here. And then what we'll do is we'll do if, and we want to do a check here. And we want to do if y is less than, and we want to do column height here. If it is less than, then we will do all of this. Otherwise, we will simply, so we need to do a little else here. We will simply add a column block, or we will add to the chunk blocks here. So chunk blocks at xyz equals a new block. And this takes in the two arguments. So the first one is the new vector3, which is the x, y, and z. And then the second one, we will do block type dot empty. And here we are actually going to specify block type dot dirt. And so now what this is basically saying is that we are looping through the entire size of the chunk, and we are looping through the entire height. But if the height, the current y of this for loop is greater than the column height that's generated by our height map, then just put an empty block in its place. And you'll notice that we are not adding the faces of our empty block here because we don't want to do anything with this empty block. It's simply a representation of a block. And so now that we have this, we can get into some more stuff here. So what we're going to do now that we have this all set up is we're going to move where we are adding our faces to a separate method. And so this is going to be a public void gen faces. And this is where all of this logic is going to be. So we're going to do another for loop. And this is going to be the same idea. So just a looping over the x and then looping over the z, making sure that it is size, not height, and then looping over the y. And now we are doing this extra loop here, and we are going to do this. So we want to get rid of the faces that are not wanted here. So we're going to get rid of this first. And we are going to make this a little more efficient. So I'm going to put this on one line now. And you can see that that makes that a lot more efficient. We're going to be doing the face adding logic in the gen faces, which we are going to call after this. So we will simply call after gen blocks, we will gen faces. Let's go to the gen faces and let's have some checks. So let's do the left faces first. And by the way, little disclaimer, this is not going to be the absolute most efficient method. This is something that is a little bit simpler to understand, a lot simpler to understand than things like awk trees and like greedy culling and all that stuff, or greedy meshing, sorry. So this is going to be a little more simple to understand. So that'll hopefully clarify some things. We're not making a super ultra optimized version from the get-go. So what we're going to do is we're going to do the left faces. And so what is this? So the qualifications for the left face. So the qualifications are going to be the block to the left is empty, and that is it. So let's check here. And we'll check that is not farthest left in chunk. So the left face follows the x-axis. So what we'll do here is we will simply do if, and we will do x is greater than 0, and now we do the check. And so this will be the check here. So what we're going to do is we are going to do if, and then we need to do chunk blocks. Whoops. If chunk blocks at, and then we need to do x minus 1, y, z dot type does not equal, or actually equals block type dot empty. If it is empty on the one to the left, then we want to add the left face. So we will do integrate face, and then we will do the block, and the block is going to be the chunk blocks, chunk blocks at x, y, and z. And then it's going to be the face, so faces dot left. And then we're going to add an else statement to this if x is greater than 0, because if it is not, that means it's on the farthest left. So we will just simply add it without this check. And so what we'll see with this here is that we should generate only the appropriate left faces. And we go over, and it seems like that did not work fully. So let's check. I completely forgot. We need to do this. We need to do int num faces equals 0, and then we need to increment here. So we need to do num faces plus plus, num faces plus plus, and then we need to simply add the indices and send it the num faces. This should fix our issue. All right, so we are seeing all of the left faces, although I think we are actually seeing the ones that we shouldn't see instead of the other way around. So that actually shows that it kind of works just in the opposite direction. So I think the reason is because of the issue here. So yes, what we need to do is this. The first thing that we need to do is we need to change this height to the column height. I forgot about that. So we'll do int column height equals height map, equals our height map. We need to actually send the height map again. So float height map equals the int typecasted version of our height map at x and z. Whoops, IntelliSense is not helping me today. X and z divided by 10, and then replace this while loop to go up to only the column height. I believe that should remove the ones all the way up there. I need to send the height map here. And now if we look around, we should see that we have one pane, and this is because I think our chunk is on a slope in the opposite direction, so there actually aren't any other necessary left faces. Let's make sure by adding our right faces. So let's add our right faces real quick. Let's go to these right faces and let's do right faces. And the qualifications are the same thing, except just block to the right is empty, and it is not the farthest right in the, or is farthest right in the chunk. I should change that, yeah. So now what we're gonna do is we'll literally just copy this over, and what we'll do is we'll do if x is less than size minus 1, and this means that it is not the farthest right. Then we need to do if x plus 1, and this should all work fine here. So what we can do, actually, yeah, this should work here. So now what we can do is we can run it and see if this will work. We need to do faces.right though, and faces.right. We might get an error with that size minus 1. It might need to be size minus 2, though I think that should work. Yeah, now we can see all of our right faces have been added in correctly. So this is everywhere where a right face appears inside of our chunk. So nice, it's a nice little, it's cool to visualize this. See how many faces do we actually need here. Okay, so now let's handle the top faces. Top faces. Now the qualification, let's go here and let's copy it down. The block to above is empty, and the farthest, or is the farthest up in chunk. And so we can do this, and we can simply say if, and we want to do y is less than size, or not size, y is less than column height minus 1, else add it. So just simply add it here. And then otherwise we can do this check here where we do if chunk blocks at x, y minus 1, or y plus 1, my apologies, and z dot type equals block type dot empty, then integrate the top face. Now if we run this and all goes well, we look over and we see our top faces, every single one of them rendered properly, and we have no extra top faces. So that all worked perfectly there. Let's render some bottom faces. So let's do bottom faces. And I know I'm walking through all of them, but sometimes it can be a little bit hard to think about one for a bit. So this means that the block below is empty, or it is the farthest down in a chunk. And for this, we can reverse our top face, copy and paste it. If y is greater than 0, then we will simply do this, and that should be it, except faces.bottom, run it. And we look over, we have our bottom piece here. And while there are a lot of, this isn't perfectly efficient because you don't actually need to render the bottom, I'm just showing a general example. We can get into extreme optimizations in future episodes. So let's do the front and the back to complete these blocks. So the front face. Now the front face, I believe that the front face moves negative towards us. So what we're going to do is we're going to do if, and we will do z is, and then we need to do less than, and we need to do size minus 1. Then we will simply check here. So we'll do if, and we'll do chunk blocks at x, y, and then z plus 1 dot type equals block type dot empty. We're getting an error. No, we're not. And we simply need to do again the integrate face in the chunk, faces dot front now, and then else we simply integrate it again there. And now let's do the final one, the back face. Copy and paste this. Change this to z greater than 0. Change this to a -1. Change this to the back. And let's check. I always forget the I forget the order if it's z goes positive or negative. It's my thing I always forget. But let's check. See if we got it first try. We did. All right, look at this. The entire chunk is rendered with terrain and proper chunk meshing. So now you can go inside of here and you can see that none of the unnecessary blocks are rendered. However, I don't know if you've ever used the Minecraft glitch where you can go inside of a block and you can see throughout everything and all the chunks, and you don't see these blocks here. And the reason is because it uses backface culling. And so we're going to be using some backface culling here to ultra optimize this. And so to do this, it's actually insanely simple. All we have to do is we can simply go to the on load here, and where we are enabling the depth test, we can do the GL dot front face, and we're going to change the front face direction to clockwise since we created ours with a clockwise orientation. If you did not, if you did different vertices, check which direction they are going in your indices, because by default it is counterclockwise. Now we need to do gl.enable, and this is going to be the enable cap.cull face. And now we need to set the direction, so gl.cull face, and we need to do cull face mode .back, and that is it. So now we can run it. Look around. Actually, we're inside of it. That's why that shows that it worked. We are here. We can see everything outside. We can see all this. But if we go inside, we can't see these blocks because they are in the back side. We don't see the back faces of blocks. So we have gotten ultra optimized here. We are only rendering the absolutely necessary block. And so, yeah, that's it. That's basically the simplest way that I could think of to do some basic chunk meshing and only render the appropriate faces. So with that being said, thank you very much. If you have any questions, make sure to leave them in the comments or join my Discord. I will be responding to questions more actively on Discord. And consider supporting me on Patreon. It would really help out with making these type of videos. Thank you very much for watching. Have a good day. See ya.